Welcome all. In this video, we will learn about superposition theorem. Students will be able to analyze the circuit using superposition theorem. The superposition theorem can be used to find solutions to network with many sources. That is, the current through or voltage across any element of a network is equal to the algebraic sum of the current or voltage produced independently by each source. Since the effect of each source will be determined independently, the number of network to be analyzed will equal the number of sources. That is, number of network to be analyzed is equal to number of independent sources. Applying the superposition theorem to a circuit, select a single source acting alone, short the other voltage source, and open the current source if internal resistance are not known. If known, replace them by their internal resistance. And then find the current through or the voltage across the required element due to the source under consideration using a suitable network simplification technique. Repeat the above steps for all the source and then add the individual effect produced by individual source to obtain the total current in or voltage across the element. In the figure, to find out the resistance current across the resistance R4, first select a single source acting alone and then short the other voltage source and open the current source if internal resistance are not known. If known, replace them by their internal resistance and then find the current through or the voltage across the required element. That is, here we have to find out the current through the resistor R4 and then due to the source under consideration using a suitable network simplification technique, and then repeat the above steps and then add the individual effect produced by individual source to obtain the total current. Maximum power transfer theorem. In an active resistive network, maximum power transfer to the load resistance takes place when the load resistance equals the equivalent resistance of the network as viewed from the terminals of the load. So, a load will receive maximum power from a network when its resistance is exactly equal to the Thevenin's resistance of the network applied to the load. That is, RL is equal to RTh. For analyzing the circuit using maximum power transfer theorem, first calculate the Thevenin's voltage VTh or Norton's current IN. Then calculate R equivalent as viewed through the load terminals. Then draw Thevenin's equivalent or Norton's equivalent and find out at which condition RL is equal to R equal. That is, that gives the condition for maximum power transfer to load, and then find out the maximum power transfer by the equation P max is equal to VTH square divided by 4 R equivalent.